Hello everyone and welcome to today's video. In this video I'm gonna start with a short video which I took few minutes ago, and it demonstrates how the ultrasonic sensor responds to an object in front of it and stop the execution of the motors. So let's start the video. As you see, the program is loading now and the motors started, and it goes slowly to front and it reaches the distance of 10 centimeters, and as soon as it gets to the 10 centimeters distance the motor stops and the program shut downs. And as you see, I started the ultrasonic sensor in front and the touch sensor on the back. So the, what we want to do as a next step is that to control the movement of the robot going forward and backward, and using the sensor information to control the robot in order to change the direction and pass the object in front. So the obstacles coming in front of the robot during moving forward should be take care of using the sensor information in order to change the direction of the robot and go past through the obstacles. For the moment, our code has a flaw, and I want to also to share the information with you. I've implemented the listeners for the ultrasonic sensors and touch sensors, and to keep the implementation generic, first of all, I designed an interface. In this interface, it's regardless what kind of sensor we are using. We have a method on sensor sampling, which start the sampling. We are setting a sensor, and also we register the control, the robot control. It should be, and the other thing is that now the sensor listener, we have now two sensors mounted on the top of the robot rig. So we have an ultrasonic sensor which implements those methods, and also on the constructor we set the sensor. So whenever we are instancing an ultrasonic sensor listener, we are passing a sensor object to, and as you see, the set sensor accept an object, and depends on what type of sensor listener we're implementing. We're doing a typecast to be able to access to the dynamic instance of the instance given inside the constructor. Uh, Basically, the beauty of this implementation is that if we go back to the app, as you see, uh, in a handler, I have an add sensor listener method, and this add sensor listener method has a parameter which accept the eye sensor, the interface, the sensor listener interface. And sensor listener interface, as soon as each sensor listener implements this interface, I can pass them to the sensor list. So let's go and take a look here in the motor handler. So in the motor handler class, we have a list of the listeners, and the list of the listener is a sensor listener, is a type of the sensor listener. So the static type of the listeners are sensor listener, but when I'm initializing an object of this interface, because I cannot initialize an interface as an object, I'm implementing a class. I'm implementing this interface in a class, for instance, touch sensor listener, and I'm passing this instance to the sensor listener. The static type is always the sensor listener, but the dynamic type is now the touch sensor listener or ultrasonic listener. And since both of these classes are implementing the methods inside the sensor listener, so they are compatible. So I just simply when I'm back here, when I'm calling on sensor sample, the dynamic type of the implementation will decide what method should be called. And since we have now two type of the sensor listeners, when I'm calling on sensor sampling, when the dynamic instance of this listener is touch sensor, it's gonna call this implementation. And when it's the dynamic type is the ultrasonic sensor, it's gonna call this method. And this is the beauty of using the interfaces to generalize the implementation and also make the code robust to the changes. So as you see in this on sensor sampling, I have two guard conditions. These two guard conditions prevent the further process if these two uh, fields are empty. So whenever I don't have a control or sensor, the sampling won't continue and it will throw an exception. And the other thing that we need to consider is that I'm at the moment when I go back to the motor handler, when I'm calling this method, I'm not doing error handling. So the other thing that I need to implement is that to handle those errors. So whenever this guard conditions happening, I should also take care of those conditions, those exceptions here. So I need to do error handling here. And the other thing that is important is the parallel executions. So as you see that I'm calling the on sensor sampling here, and on sensor sampling for each implementation is different. For instance, let's take a look at the ultrasonic. So what's happening here that I'm starting sampling the sensor and I'm doing it till the sample is, so as soon as the sample is bigger than the threshold or the execution is not stopped, I'm doing this sampling. And this loop is a problem. Why? Because when I'm going inside this loop, I cannot uh, send the control for flow outside this method. So whenever I'm calling on sensor sampling, the control flow will goes into this implementation, comes here, and will stuck here till something happens. Either the sampling ratio gets smaller than threshold and the execution is shut down. So this is a problem because it causes the control flow to stops in a certain point inside one of those implementation, and I cannot access my touch sensor uh, because my touch sensor is not yet called because the control flow is inside the ultrasonic sensor, and because it's a single thread now, it's actually we have two threads. The first thread is the main app, and inside the main app we are submitting in the motor handler a second thread, and this thread is a single thread, and all the listeners and the motors are inside this thread. Calling those methods are inside this thread. And the problem is that now we are stuck into the ultrasonic and we cannot go further till something happens here and we go further away and then we can continue. So we should find a solution to solve this problem. And one of the uh, one of the possible solution could be using the event-based systems. So we should start doing this and even execute this thing in another thread. And whenever something with this thread happens, it will fire an event, and this event should be sent to the other parts and so notify the other objects considering the state of the program, and then doing the corresponding behavior that we will design later. So this is all for this video, and I also wanted to show you that I organized the project and different packages. So each package show me to what I'm expecting inside. So in this package, I'm putting a controls. And why is this? It's simple because instead of having a method with the number of parameters going inside, I can simply design an data model, and in this data model I can store all my values. For instance, in this case, I'm storing motors and services inside the control, and I'm passing the control to my listeners so they have access to all the motors and services using the control instance. And basically I'm giving the listeners the, if we talk about the instances, we are not instancing an parameters, we are giving the address of these instances further to our listeners so they have access to these instances too using the addresses, and then we can use this information to control our robot or brick at this point. So thanks for watching this video. This is all for today, and in next video we will discuss a solution for the problem that I'm just showed you, and also you will find the implementation inside the Git repository, and I wish you a nice day. Thanks.